Hello everyone, I am Uveshwara. Today we are discussing about that class 12 physics chapter number 8 electromagnetic waves. In this chapter we are discussing about the electro and the magnetic. Okay, there are the two fields are there, electric field and the magnetic field. Due to the electric field and the magnetic field there are the one wave will be generated. So they are today we are discussing about the electromagnetic waves. Okay, in this topic we are discussing about the introduction of this chapter. After that another topic is that the displacement of current, displacement current. Okay, so in this chapter we have shown that there are the theoretical chapters. So we have shown that the what is uh, what is the relation between the electromagnetic waves. You know that about that. First of all, electromagnetic waves, it is related to us. How? Because we are using the phone, because we are using the internet. So internet, it is a one type of electromagnetic waves. Okay, there are the electromagnetic waves. So due to these waves we can communicate to each other, we can communicate to broadcasting system, we can communicate the radar system. So this is all the things are that the related to the electromagnetic waves. Suppose we need to we have I was told you about that. But whenever we are discussing in the underwater, on the time which way we are using. So on the time we are using the sonar system. Okay, in the earth of the upper part of the earth, on that time we will using the radar system. Okay, and whenever we are talking about that the underwater, we are discussing about that the sonar system. Okay, we are discussing about that the sonar system. So there are the sonar systems. So it is a sound navigation and ranging system. Okay, sound navigation and ranging. So on that time it will be also the why we are using the sonar, where we are using the sound. The sound will, due to the sound, because of the sound will be more travel underwater due to the water. So it will be, it has a approximately 1400 meter per second velocity. Okay, it is the velocity is 100 meter per second, and on the earth it will be maybe 343 or 333 meter per second velocity. So that's why we are using the underwater sound, and on earth we are using that the electromagnetic waves. So electromagnetic waves, it is a today's basic indeed of our of us. So if there are the no electromagnetic waves, then we cannot use the internet, and then we cannot use the computer. So this is electromagnetic waves, it is the our basic indeed. Okay, so we are going to the introduction portion. See here, electromagnetic waves. So in the electromagnetic waves, there are the two phenomena is there. First one is the electro, and the second one is the magnet. So electro, it means we are discussing about the electric field, and the magnetic, it means we will be discussing about the magnetic field. In the previous chapters we have shown already, but I will show you in the chapter number 4 and chapter number 5, chapter number 4 to 6. There are the lots of topics are remain. So we will discussing in the chapter number 4, 5 and 6. On that time we will discussing about the magnetic field. So see here, there are the first of all electromagnetic waves. So see in this chapter, introduction portion, this is our introduction portion. So first of all we learn that the electric current produce the magnetic field. Okay, what happened whenever the electric current produce the magnetic field, and the two current carrying wires exert the magnetic force on each other. So in chapter 6 we have seen that the magnetic field of changing with the time gives the rise to an electric field is, and the converse also true. So does an electric field changing with the time gives rise to the magnetic field. Okay, whenever we are shows that the whenever current will be passing through any material, on the time the surrounding of the material, there are the magnetic field will be generated. So similarly, whenever see here the magnetic field and the two current carrying wires exert a magnetic force on each other. So we have seen that the magnetic field changing with time. We have shown the induction. Okay, in the previous, like the transformer, we have shown that the induction. So induction where is the magnetic field also is generated. So due to the magnetic field of induction, there are the generated in the current. So similarly here the magnetic field changing with the time, gives rise to an electric field. Is the conserve also true? Does and it means whenever the magnetic current will be passing through the current, on that time magnetic field will be generated, and another thing is that when the magnetic current field changing with the time gives rise to electric field, it will be produce electric field. So does an electric field changing with the time gives rise to the magnetic field? James Clerk Maxwell argue that this was indeed the case. Not only an electric current but also time varying the electric field generate the magnetic field. Okay, what we will say, the Maxwell was told about that whenever we are changing the, first of all we are shows that the electric current, but what happened, the electric current but also the varying the electric field generated, we have shown that the magnetic varying the magnetic field, on that time electric field will be generated. But see here, whenever the electric field will be generate the, whenever the electric current but also time varying the electric field generate the magnetic field also. So it will, we have the, if the we have the, electric field vary on the time, what will happen, there are the current will be or electric field will be also produced, and also magnetic field. While applying the Ampere circuit laws and to find the magnetic field at the point in outside a capacitor connected to time varying current, Maxwell noticed the inconsistency in the Ampere circuit law. Okay, first of all, Ampere circuit law I will show you. It suggests that the existence of the additional current called by him displacement current to remove this inconsistency. Okay, what will happen when the time varying the electric field generate the magnetic field while applying the Ampere circuit law? Okay, so first of all, what is Ampere circuit law? See here, Ampere circuit law. There is an alternative and the applying way in which the Gauss law may be expressed. Ampere circuit law. Consider an open surface with the boundary. The surface has current passing through it. Okay, see boundary and the surface. Okay, consider an open surface with a boundary. This is open surface and the boundary. The surface has current passing through it. We consider the boundary to be made up of number of small line element. Who consider on each on such element. Consider on such element. So consider on such element. Consider one such element of length dl. Okay, there are the length is dl, and we take the value of the tangential component of magnetic field bt, that is the bt at this time, and multiply by the length of the element dl, not the bt into dl, it is equals to b into b dot dl. All such product are added together. We consider the line limit has as the length of element gets smaller and their number gets larger. The sum then tends to an integral. Ampere's law state that the integral is equals to mu 0 times the total current passing through the surface is integration of b into dl, it is equals to mu 0 into I. So b is the, what is the b? B is the magnetic field. Here what will the, how much magnetic field is there, and the length dl, how is the length of these things. So we will get that the integration closed loop of integration of b into dl, it will be gives us the mu 0 into I, where mu 0 is the, what is the mu 0? Mu 0 times the total current passing through the surface, and I is the total current passing through the surface. Okay, total times of the mu 0, what Ampere circuit state that is equals to mu 0 times the total current passing through the surface. So b integration of b into dl. So mu 0 is where I is the total current through the surface. The integral is taken over the closed loop coinciding with the boundary c of the surface. The relation of the inverse sign conversion given by the right hand rule. Let the figure of right hand be called in this sense. The boundary is transferred in the loop integration of b into dl. The direction of the thumb gives the sense in which the current I is regarded as a positive. Okay, so we have seen see here the ambiguous circuit law of magnetic field. We have shown that the integration closed loop integration of b into dl. But now we will discussing about that the Maxwell formulated set of equations. Okay, there are the they are producing the set of equation so involving electric field and the magnetic field. Okay, so before that Maxwell equation we shows that the only electric field when we are varying the electric field on the time just to generate the magnetic field. But after that the Maxwell was told about that there are the no, this phenomena is not correct, but correct is that electric we have there Maxwell was combining the electric field and magnetic field, and the sources, the charge and current density and the current. See, this equation are known as the Maxwell equation. There was derived another equation. Okay, there was derived another equation, and this equation was known as the Maxwell's equations. Okay, together with the Lorentz force formula. The Lorentz force formula, the F is equals to Q into E plus B Q into E Q into E, sorry, F is equals to Q into E plus V cross B. Okay, there are the, this is the Q into E plus Q into in bracket V cross B. So this is the Lorentz force formula. Okay, this is the Lorentz force formula. So mathematically express all the basics law of the electromagnetism. The most important prediction of the emerge from the Maxwell equation is the existence of the electromagnetic waves. Okay, there was prediction that the electromagnetic waves are generated, so which are the time varying electric and the magnetic field that propagate in space. What will happen, the time varying the electric and the magnetic field on the time that propagate in the space. This speed of the waves according to this equations turn out to be very close to the speed of light 3 into 10 raised to 8 meter per second obtained from the optical measurement. This leads to the remarkable conclusion that light is an electromagnetic waves. Maxwell's work thus unfit the domain of electricity, magnetism and the light. Hertz in 1885 experimentally demonstrate the existence of the electromagnetic wave. Maxwell worked the unified the domain of electricity. What will the magnetism and the light. Hertz in 1885. Maxwell's work thus unified and the domain of electricity, the magnetic and the light, magnetism and the light. Hertz in the 1885 experimentally demonstrate the existence of the electromagnetic waves. It technological used by the Marconi and other led in due course of the revolution of the combination that we are witnessing today. Okay, we have shows that the electron, due to the electromagnetic we are using the lots of things is there. So in this chapter we first discuss the need for the displacement current and its consequence. Then we present a descriptive account of the electromagnetic waves, the broad spectrum of the electromagnetic waves stretching from gamma rays. Electromagnetic wavelength is 10 raised to minus 12 to long radio waves wavelength is 10 raised to 6 meter is described. Okay, there are the range between the gamma rays to radio waves. There are the ranging of this wavelength is 10 raised to minus 12 meter to long stretching from the gamma ray. How it will start from the 10 raised to minus 12 meter to the long as radio wave 10 raised to 6 meter is described. How the electromagnetic are sent and received for the communication is discussed in the chapter number 5. Okay, see here, this is the Maxwell equation. Integration of closed integration of E into dA is equals to Q upon epsilon 0. This is the Gauss law of for electricity. This is in Maxwell equation in vacuum. Okay, so see, integration of B into dA it is equals to 0. Gauss law for a magnetism. Integration of E into dl is equals to d phi by d phi b upon dt, Faraday's law. And also integration of B into dl it is equals to mu 0 IC plus mu 0 epsilon 0 d phi upon dt. It is also Ampere Maxwell's law. Okay, this is the Ampere Maxwell's law. So in this is the Maxwell's equation. We have discussed about it in the previous slides, Maxwell's equation. So this is our Maxwell's equation. Due to the this equation, we can solve the one thing, many things. We can solve the many examples. Okay. So see here, after our the another topic is displacement of current, but we will discussing in the next lecture. Okay, thank you guys, thank you so much. If you have any kind of problems, if you have any kind of query in these lectures, then comment in the comment box.